How's everybody doing today? Well, yeah, good? Hi. Hi. How's everybody? Okay, here we go. Let's do this. So, today I want to talk a little bit about design patterns in configuration management. This is something that I love, absolutely love. I talk about this with pretty much anybody who will listen to me. So if at any point you want to come talk to me about this afterwards, please find me. I will be glad to rant with you, rant at you, whatever. But what I want to talk about today is a lot of what's been kind of encompassed in the spirit of this talk, of this conference, which is just amazing. The spirit of this conference has been, there is a transformation happening here in IT today. Businesses need IT to accelerate their business, which means as an operations person, I now have to have a better and more intimate understanding of how the business operates in order to be successful, to help them grow. That's a little bit of a different paradigm than we're traditionally used to as a system administrator, where I mostly focus on the technology. Out of a lot of this kind of thought and thinking about configuration management and the design patterns comes what I'm going to talk about today. Some of this is high-level stuff. Some of it is very nitty-gritty. But the overall arching theme is we want to figure out how to accelerate business. And some of the things I'm going to talk about today help agility, help administration, help sanity, helps your day-to-day. With every presentation, I like to start with a story. So once upon a time, there was a server. There was a cloud. Hundreds and hundreds of servers everywhere. And one of them has a bad day, and it fails. Maybe it runs out of CPU, it uses too much CPU. Maybe it runs out of disk. Maybe it can no longer communicate with its network. Something happens, the server has a bad day. Can you see which one is having a bad day? Yep, you guessed it, that one right there. But anyways, what happens? This thing has a problem, and somebody gets called. I get called. My friend Aziz gets called. We get called. You get called. Come fix this thing. Hopefully it's not at like 3 a.m. in the morning. Worst time ever to get a phone call. But anyways, you wake up, or you go to work on this thing, and you fix the problem. Takes a little bit of time, you investigate around it, maybe see if you can patch it up to make sure it doesn't happen again. And then you move about your day. This is how we operate today. What's wrong with that? Why does a human have to touch this? Shouldn't have to. I should not have to wake up at 3 a.m. to fix a disk space alert or too much memory. Why can't a robot do it? A robot should be able to do this. But because of how we operate and how we're just kind of focused on the day-to-day, we don't think about the big picture. So we have to step back a little bit. The challenge is we think about things on a micro level. Even today's tools, think about things on a micro level, a resource, a file, a service. Not an actual offering, a service catalog. And what's worse is the complexity of our systems keeps scaling infinitely. We keep getting told there's these easy self-solutions, but the challenge of it is that as your businesses grow, their complexity increases, which means the underlying technology stack has to maintain or accelerate, stay in front of that business driver in order to continue to be effective. So I talk about this a lot in other presentations, specifically about design-driven infrastructure. How do you make this thing? What are some of the qualities of a true design, data-driven infrastructure? Right? Again, we're thinking on the micro, but the macro is there's not a collection of systems. There's not one node. There is a system, the system that powers your business. Just because computing power and disk storage and load balancing on different assets does not mean it's not part of the same system. We tightly couple things together today. So tight that when you have to make a change, the engineer wants to pull their hair out. Because they have to untangle a giant foil ball of all the different mistakes and changes we've made over time in order to keep the business running. We don't really have a modular approach today as a general rule throughout the industry where if something breaks, I can just swap it out with another component. On the hardware level, we're pretty close to that, but on the software level, we have a long ways to go. And we have all of this computing power all over the place, and yet we're still very central in how we manage things. Why can't the endpoint make decisions for itself? It's got the power. Most of the time, my machines sit idle. I don't know about yours. This is why virtualization is so great. It's because we're able to pull more out of that hardware. But we have that power sitting there for machines to make intelligent decisions about what to do. And then back to our original point, the things have to be able to correct themselves. They have to be able to understand, I am broken. How do I fix myself? And this is utopia that I'm talking about. There's a long road between here and there. But this is where we want to go. So this is what I'm going to talk a little bit about today, the voyage that we're on. So hi, my name is James Fryman, and I work at Github. I'm an operations engineer, and I spend pretty much every of my waking moments thinking about this problem set. Not in the general sense for GitHub, but for the everyman. How does an infrastructure, an autonomous infrastructure exist for everybody? You don't have to think about it. As an administrator, I don't have to think about the individual systems. I can think about the control systems that monitor these things, that manage these things. So I'm in a corgi mood. So here's a picture of a cute corgi. Kind of soak it in, feel the love. But what I want to do is I want to point out this web address here. http://git.io/in341A. If you follow this website, there will be things that I talk about that are very difficult to represent on a slide. There's only so much you can fit on these things. So if you want to follow along in more depth as I'm talking, or even afterwards, this is where you want to go. All the links that I talk about are in here. And if you happen to have your phone out and you're interested in this, if you would tweet it to somebody, that'd be amazing. Everybody can follow along with us. So let's dig in. In one of the presentations that I gave recently about data-driven infrastructure, one of the challenges that I talk about is that we don't have an appropriate language to describe some of the things that I'm talking about. We have really great configuration management tools like Puppet, CFEngine, Chef, Ansible, Salt that help me think about things on a very micro level. What's the service? What's the file? The resource. But in reality there's only one happy path that I can describe with these tools today. Most of them. There is an exception. We'll mention that at the end. But I really only have the ability to describe one happy path. But in reality, computers are very complex. The one system is going to require many steps in order to make it so that it can go do something. I can't just start up a web server anymore. There's no such thing as a single web server and a single database. We're talking about tiers of these things, hordes of databases, which require some amount of orchestration between these things. So you have to be able to make complex decisions. But today's tools really kind of don't help me with that. So I don't have the appropriate language. But in reality, what we're trying to describe here, and this is actually activity on node is a concept from actual physical logistics, right? So we're able to steal really great concepts from people who've already solved this problem set and see how we can apply them to our own state, to our own systems. Because in reality, computers are just complex state machines. And it's more than one path that we have to be able to describe. We have to describe many paths and describe the complexity in a better language that now the computer can make decisions about things. Because there's a life cycle for every machine, right? There's a provisioning stage, which may or may not require coordination with other nodes. What about a maintenance state? The first problem that happens at GitHub is when we have to go do maintenance on a thing, we turn off our configuration management. It is the antithesis of what should happen. The configuration management should not be fighting with us, it should be helping us. And yet it does. We don't have good retirement methods. We have the one path, the one good state that makes this node ready to serve something. And likewise, there's a self-correction methodology. Today, we have an operations engineer like myself who has playbooks and step-by-step instructions on how to dig in and resolve a problem and all the different triage steps that they need to go to. And they're not always linear. Sometimes they're very complex and they go in a bunch of different directions. I can't model that today. And if I can't model that, how's the robot going to do it? Can't. So in discovery of this, I created a state machine engine for Puppet. Should be on like one of the first or second links on that Git link. Actual code that helps you create many states within Puppet and how to transition between those things. So this is where I'm going to get a little technical here. I'm actually going to dive into the actual pattern that gets used here because there's a lot of applications here. In software development, there's this thing called the proxy pattern, where something is requested, it's routed somewhere, and then an asset's served. We think about this. We have proxy servers. We do this on the network layer, right? We are able to instantiate classes in code and pass them through to something else. But our tools today don't really allow us to do that, or at least we haven't dug into it yet. Here's some code, and if you don't speak Puppet, that's okay. My goal here is to talk about both the concepts and the code. So if you're with me on the code, let's do this. But what's really interesting here is this proxy pattern is that I am now doing a little bit of metaprogramming. And what's cool here is I can provide this state machine as a resource for somebody else to use. Now, who's your audience when you're designing infrastructure and you're developing infrastructure? If the answer isn't your developers, or the people that are accelerating your business, you're thinking about the problem the wrong way. And I don't want to be able to have to give a whole Puppet stack to a developer. That's a little bit much for them. They've got enough going on, right? But now, with the proxy pattern, I'm able to abstract an idea to them, this state machine. And how it's executed is my decision. Maybe I want it to be local. Maybe I want to write to Zookeeper. Maybe I want to write to wherever. And now, with this code, I'm able to dynamically define where this message gets passed using the proxy pattern. Pretty simple, right? And in order for a state machine to work, the node has to be self-authoritative. And it has to be able to say, what state am I in? Today, in the Puppet world, this is done with factor. I have to give something back to the Puppet master to be able to say, here's what state I'm in. And so we're able to fake out this thing a little bit by using an application that will jam its state upstream. And then I can define any number of arbitrary backends, This is a very simple example. It's just mostly a spike for the purposes of this conversation. But I can overload this with anything, assuming that I create a class for my systems that responds to the messages, what's the base and what's the state? Well, now suddenly, things get really interesting. Just to kind of wrap up the state machine part here, what I want to be able to say, though, is that as soon as I declare this thing, now I no longer have to do anything else but define the states themselves and what they're supposed to do. Now, this is interesting because in a Puppet world, in a declarative world, I can't define multiple states. I can't define multiple resources with the same parameters, attributes, or in the same ideas. I will run into resource conflicts. But with this, now I have entire fenced blocks that'll get called only when I'm in a specific state. Cool. Interesting to talk about. Code. Go play with it. It's there. But here's why this is important, okay? Because now with the state machine, I'm creating a method and a set of constructs on the system that now configuration management becomes part of the system, not an individual piece or separate from everything else. I can now integrate it with the rest of my stack. Things like, how do I change configuration parameters on the fly? Using a thing that we do at GitHub called ChatOps. Should be a link in the gist for that. If it's not, I'll update it. I think I got one in there. But what about a response to a global state? I'm supposed to sync with something, this database server, this load balancer. I have to wait for it to be ready. What if your configuration management solution could do that? Well, this tool could help you. But here's the real power of the proxy pattern. So I'm kind of overloading this. There's two things I'm talking about. The one is the state machine, and one is the proxy pattern. Well, why would I create and use this pattern if we've already got this already proxied down in Puppet? I can already create defined resources and types using their resource abstraction layer. Chef has a concept of this, Ansible has it. They all have a concept of this. But it's on the individual resource, it's not on the macro. The macro being, okay, so I've got this state machine, I'm sending messages through in order to accomplish things, but I want to expand on that. What if I turned it into an actual factory? And that factory, there's where the real magic comes in. Now, I'm able to give constructs to my developers that isn't like, go spin me up a MySQL server and go figure out what's going on. Go put the onus on the developer to go set up monitoring, or to go set up logging, or to go set up metrics collection. That's a lot. But now I can use the proxy pattern to start to overload things and create services for my developers to consume. I want my developers to consume a database service. I want my developers to consume a load balance service. Should they care what's on the back end? No, not really. That's your job. Figure out how to keep it running. But now using a pattern like this, they go instantiate a new database. It comes with everything for free. You can set up all the constructs that you need for your business and pass it through. And let's say it changes, and suddenly you need some modularity and you introduce a new database. Well, using the proxy pattern, just instantiate a new class. What's the new class going to be? Is it going to be a Cassandra server? Is it going to be a Postgres server, MySQL, whatever? But you don't want to have the developer giving them all these parts. You don't want to say, hey, here's a bunch of pieces, go build yourself an engine. Who knows how to do that? I don't. Sorry, I can't. I want this. I know I want an engine. I know I have a car to put it in. I want that. This is what we should be building. But there's too many choices. Too many choices today for developers, even operations people. How do we use these tools? Where do I put these constructs? How many times do I have to touch my configuration management solution in order to get something to happen? Today, too many times. I postulate that if you have to touch your configuration management solution, one time you have failed. A computer, again, should be self-authoritative. Should be able to say, I want to be a load balancer. I want to be a MySQL server. And configuration management tools should know how to provide that with zero touch. Because the robot has to do it, remember? This is where we want to get. So here's another tool. We call it ladders. And what ladders does is it mimics Hiera. So if you're familiar with Puppet, Hiera allows you to abstract data from your classes and your defined types into a data store that's outside, external. It could be a flat YAML file, it could be a database of some sort, whatever. But its underlying concept is sound, where based on the set of metadata that a node provides to the upstream, it knows what data, the Puppet master knows what data it should give it to. Why can't we use that same concept to determine what a node should be? If I wake up and I say, I'm on the Linux server, I should already know what a Linux server looks like and not have to touch it. If I wake up and say, I want to be a MySQL server, that should be great. I should be able to say, make me a MySQL server. Stacks and ladders allows that. And here's some nasty code. This is also in the gist, so you don't really have to grok this all that much. But this steals another pattern that I've talked about called auto-loading and convention over configuration. We talk about this a lot in other places. Rails is a big community that does convention over configuration, where based on what is set, what metadata, things automatically happen. And that's where we want to be. We want to be to the point with zero touch. And with this, all I have to be able to do is define, here is the metadata that I care about. Based on that metadata, go do one of these things. And again, these could be fenced, completely separate. I can create more than one happy path and create many paths. And all these tools, they fail open, which is interesting. This is another problem we run into. When I break something, I break something a lot. Let me just be honest with you. I break a lot of things. This is how I experiment. But when I break something, I don't want it to affect my friend Aziz. Today it does. I break something in the one happy path and suddenly nothing can be deployed. Has that happened to anybody? Okay, somebody's raising their hand. That's good, right? My work should not affect his work. Your work should not affect my work. Today it does. All of these tools fail open purposely because I do care about some underlying substrate. I want the latest security patches. I want the latest operating system updates. But I don't want your broken code affecting my system, nor do I even want you trying to apply it. If you fail, that's fine. I'm not going to do anything with it. But I am going to continue processing. A little bit different than how it operates today. And this is the language that we need to start building upon. All of these tools that got introduced today, state machine, ladders, all help build on that, creating a better language. Because what Puppet and configuration management tools should be in the larger scope of the system is the controller, the layer with which you define what my infrastructure should look like in a complex set of terms. You can do this today without these tools for sure, but what do you end up with? Hundreds and hundreds and hundreds of if-then-else statements. Every time I see one of those, I pull my hair out. I'm going gray early because of some of this code block that we have that's legacy that is, 900 lines long of if-then-else. It is a bear. This helps solve some of this. But it also helps us to solve the interdependency problems between multiple states and allow convergence to happen in small chunks as opposed to trying to have it happen all at once. And I got really excited when I got invited to this conference. And I wanted to talk about all of my ideas. Unfortunately, I only had about 25 minutes. But the good news is I have a ton more to talk about, so there will be more presentations. But there's different problem sets that we've solved that I would love to talk to you about as well. Things like service discovery. There's tools out there, but how does it fit into the overall scheme of your system? What about intranode communication? This is an interesting one. I was just talking to my friend Aziz about this. When your buddy has a problem, do you go to his mother and say, I noticed my friend's having a problem. What's going wrong? No, you go to your friend and say, how can I help you? Now think about how we model computers today. We do the former, not the latter. Why couldn't a node, with all this computing power, understand what's going on around it and make changes? This is a pattern we're working with. Ties in with some of these tools that we've got here. What about control rods? This is my favorite one, where the configuration management tool, you're fighting with it. I have to increase something, the number of connections I'll allow, the number of users I'll allow on a system at any one time, the amount of memory it takes for my out-of-memory killer to engage, something. Today, an administrator has to touch something. I have to wait for a convergence cycle. Because the tool that we use today is force all this stuff through the configuration management solution. But the problem is that not every change is a long-term one. Maybe it's just an operational small change. And if I have to touch this configuration management tool base, that's a fail. I should be able to have it work in coordination with these tools. And we have patterns to work on this too. So look for these in upcoming presentations. I'm really excited about them. And I want to provide a resource. There's one man who's got this right in terms of the concepts. His name's Mark Burgess. His language and how he describes it in CF Engine is still really bad, let's be honest. But how he talks about how we model systems and how we get to eventual convergence and how we manage complex states, he talks about this using science. None of these things I'm talking about here are based on puppies and feelings and rainbows. They're based on actual science, actual things that people have figured out. This is where we need to be going. We need to be working with smart people and figuring out these patterns and applying them to our own daily practices to level up our own abilities and help accelerate the business. So with that, I'm out of time. I thank you very much. If you... Like I said, I'm really interested to talk about this. Please find me. I am Jay Fryman pretty much everywhere on the internet. There's this one place with Twilight fan fiction. That's not me. But everywhere else. Or if you like email, fryman@github.com. So I hope this was helpful. Find me. Let's talk about this. Tell me I'm wrong. Tell me I'm right. Let's debate this. Because only together are we going to help figure out how to make businesses grow and expand the way that we're going. Thank you very much.
Thank you very much.